Hello everyone. Hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts related to the minerals in civil engineering and its applications on the industrial basis. Here, the minerals used in civil engineering, just like sand, gravel, and crushed sandstones, are extracted in very large volumes because they form the basic materials like concrete, road pavements, and foundations. So, copper, aluminum, and zinc, these are all also minerals which support infrastructural development through electrical systems, structural components, and protective coatings. The slides which highlights that the graphical representation where the economic value per ton on the x-axis where the extraction in volume on the y-axis. So on the basis of this, the civil engineering relies on high volume, low cost construction minerals, making it one of the largest consumers of mineral resources worldwide. As explained, where civil engineering base, that is crushed stone, gravel, sand, are explained. At the same time, in the middle, there will be the copper, zinc, aluminum. They are the global manufacturing point of view. And at the base, there will be a economic value per ton, which is maximum for electronics and technology, where diamonds, rare earth elements, or gold point of view are mentioned. So here, the civil engineering demands are massive in volumes of low cost, where high strength silicates and carbonates are required. At the same time, the technology sector relies on micro volumes of high value, which are native elements in the earth crust or in the rare ores. The minerals in civil engineering, which is the basic anatomy of infrastructure, which includes different minerals to contribute different building components, including concrete foundations, steel reinforcement, glass facades, and transportation infrastructure. So, mineral derived from various ores which provide the essential properties of strength, durability, stability, and serviceability in structures. So, with reference to the modern infrastructure, which is a combination of multiple mineral resources working together to support safe and sustainable construction activities, as explained in the picture. So, the graphical representation of data synthesis, where the strain, that is the shortening in percentage, where stress is applied on the y-axis. The graphical representation of Denby marble and the pyrite type of rock are explained with reference to the acting strain on it. So the under compression point of view, quartzite and basalt are strong, that is breaking strength is 1800 to 2600 kilogram per centimeter square, while limestone and marble are the significantly weaker, that are having 700 to 1000 kg per centimeter square breaking strength, which dictating the structural application limits. The industry point of view, the silicon and quartzite are the basic fundamental minerals. They are used on the large scale, where the quartz, that is silicon dioxide SiO2, is the primary mineral source of silicon, which is processed into high purity semiconductor materials, that is raw quartz crystal, where piezoelectric properties allowed it to oscillate at precise frequencies governing computer clocks. Silicon wafers are essential for electronic devices used in modern civil engineering technologies such as GIS, GPS, sensors, and smart infrastructure systems. Second, that rock quartz crystals are utilized for the metallurgical grade silicon point of view, where quartz is intensively melted to remove oxygen, where yielding 99.9% pure elemental silicon, which will be separated. The which these slides which demonstrates the how a common material can be transformed into advanced technological products that support engineering applications, as explained in the microchip wafer, where silicon acts as a semiconductor, allowing the precise control of electrical current at the nanometer scale or minute scale level. The electrical industry point of view, the conductors and resistors are most important and fundamentals. They are based on the copper, aluminum, and tungsten. Copper is for conductivity purpose, aluminum is for transmission purpose, and tungsten is for resistance and heat purpose. So copper is widely used because of its excellent electrical conductivity, which making it ideal for wiring and power distribution system throughout the buildings. Aluminum provides lightweight electrical transmission components used in overhead power networks, and infrastructure projects for the railways or for the commercial buildings or warehouses. For tungsten, it is valued for its heat resistance and durability characteristics, which support specialized electrical and industrial engineering applications. So, copper, aluminum, tungsten, which are separately utilized with reference to its characteristics, that is conductivity of copper, that industry standard for energy transfer due to minimal resistance. Aluminum, which is for the transmission of data, that is utilized in high voltage power lines in the terms of electric current for its exceptional strength to weight ratio. Then third one will be the tungsten, which is for the resistance or heat point of view, which boost the highest melting point of all metals, that is of 3422 degrees Celsius. Historically vital for filaments and currently used in high temperature electronic contacts in the electronics industry. For medical industry, the biochemical and mechanical utility point of view, the minerals are used that are biological needs, calcium, zinc, potassium compounds. For mechanical interventions, titanium and surgical steels. So minerals such as calcium, zinc, potassium compounds play important role in biological and industrial applications, like calcium for critical for the bone density and skeletal framework point of view. Zinc very essential for immunity function, synthesis and DNA repairing. At the same time, the potassium compounds, which are used to govern the cellular fluid balance and nerve transmission in our body. Where titanium is wall for its high strength to weight ratio and corrosive resistance properties that are also important in advanced engineering structures. These slides illustrate the versatility of minerals and their contribution to both human welfare and engineering development. Other hand, with the mechanical interventions, well, titanium that is used in joint replacement, highly valued for extreme biocompatibility and high strength to weight ratio. Second one will be the surgical steels that are specialized alloys relying heavily on chromium and nickel for absolute corrosion resistance, just for joint and replacement point of view in the orthopedic, that is medical industry. Next one will be the economic importance, that is the evaporite Diapir trap with reference to the tectonic plates. The geological structures influence the accumulation and accessibility of valuable minerals and energy resources, where understanding subsurface formation is important for geotechnical investigations, foundation design, and resource exploration. We are taking the knowledge of geological structures, which helpful for civil engineers to assess the ground conditions and minimize construction risk. So three most important point: the core, the cap rock, and the trap. So the core, which is of the salt dome, is aggressively mined for halite and potash salts, which are vital for global agriculture and fertilizer point of view. The second one will be the capped rock, which is often mined for massive quantities of elemental sulfur. And third one will be the trap, that will be the impermeable salt walls and dome layers, which created structural traps for large scale petroleum accumulation. So three basic economic importances are explained, where the geological structures do not just provide raw materials, their physical deformation creates the precise architecture which required to trap global energy reserves. Here, the engineers filled chase sheet, which explains the descriptive data in the tabulated format based on the some rock, that is quartz, calcite, hematite, gypsum, feldspar, on the basis of some parameters, or we can change the legends like visual luster and color, Mohs hardness, cleavage or fracture. Preliminary engineering applications means on the basis of some characteristics. So important engineering minerals, which include quartz, calcite, hematite, gypsum and feldspar. Each and every rock mineral have distinct physical and engineering property. The properties such as hardness, cleavage, fracture and luster, which helps engineer to identify minerals and evaluate their suitability for construction and utilization. Understanding mineral characteristics, which enables proper selection of minerals for aggregates, cement production, structural steel, plastering, ceramics and other civil engineering applications as explained. So for quartz, the application is for glass and aggregates point of view, calcite, Portland cement, hematite, structural steel, gypsum for plastering and drywall, while feldspar for ceramics and fillers. Likewise, the hardness level is also displayed with reference to each and every rock and its type. So from atomic latex to skyscrapers framework, microscopic strength is dictated by microscopic design. Stay tuned, guys. Happy learning.